Hello, everybody. Good morning, good afternoon, good evening, and thank you for joining to episode number 5 of Going Meta. Hi, Jesus. How's it
Hey,
going?
it's going very well, Alex. It's amazing. Number 5 already with a
Yeah,
bit of a delay, right? We should have been here last week, but we
yeah.
were somewhere else, right?
We were somewhere else indeed, and we had a good. I think we have the best of excuses of why it didn't happen last week. So I hope everybody is yeah, fine with us not doing the episode last week. We were in Austin, Texas, for Graph Connect, and that was so much fun.
You're right. Yeah, and I
Yeah,
have to say, full disclosure here, we were considering for a moment to actually do it live from there, but I think it was the right choice to move it by a week because there was too much going on. There were lots of people to meet and sessions to attend. It would have been a bit crazy. So I think it's a good thing that we could delay it by a week and put our full attention and focus on this session.
exactly. I think that's perfectly correct, and I think we have now the better minds to it anyway. So I mean, my jet lag is basically gone. I don't know how about yours. Temperature wise, I'm not adjusted.
Oh,
It's
that
so
was
crazy. Yeah,
that was hard.
yeah. Now I'm freezing here and putting on the thick jumpers again. Although it's 20. It's perfectly fine, but it was there. It was just almost 40 degrees centigrade. So uh,
Although, as a Spaniard, I shouldn't be impressed because, in,
no,
in, in
yeah,
Madrid, it's not unusual to hit these temperatures. But, it's probably a bit earlier in the year to experience it, especially the shock of moving
yeah.
from going from the UK. But
Mm.
yeah, it was hot. I can confirm that.
Yes, and I'm not as used to it, obviously. Yeah, cool. So yeah, maybe one more sentence on Graph Next. If you couldn't attend because you were too far away or it was just not the perfect time for you, most, if not all, sessions at Graph Connect have been recorded, and they will be put up on a specific landing page over the next weeks or so. So probably July, I'm guessing. So at some point we will put them online, and there will be announcements. So you can catch up on recordings afterwards if you wanna watch something from Graph Connect. But now let's maybe dive in. The topic today is ontology-driven knowledge graph construction, um, and
Yes.
yeah, again maybe if you watch first, is this first episode you're watching on Going Meta? It's supposed to be interactive a little bit. So if you like to participate, type question in chat or comments. So that's always open. I'll have a look out for that. Um, and yeah, with that, I guess I'll you have a slide prepared, so I'll put that
Yeah,
on screen
I've
and
literally
get yeah.
two slides just to open because
Mhm.
as you know, and those of you who have joined us before, you know that we like to go straight to Neo as soon as we can and get our hands dirty and show things rather than talk about things only. And yeah, like you're saying, Alex, the idea today is to explore. I mean, these kind of natural idea of using ontologies to drive the construction of knowledge graphs. And that might sound like a pompous name, but what we're doing here is we're using an ontology, a domain model that we have formalized, and we want that to be the contract, the shape of our graph, and we want as much as possible to use that to help us in the data load process, in the construction of that graph. So I was describing it in Twitter yesterday as we have a model, we have an ontology that defines what terms are in our domain, and this ontology can be a public one, it can be schema.org, it can be, depending on your industry or your area, a specific one. It can be one that has been created for your organization, it can be one that you create, doesn't matter. I mean, it's explicit description of your domain, and you want to build that into the data ingestion process so that you can easily write code or help writing the code that will build the graph. And by doing that, the idea is that the graph that you build into Neo4j is going to be naturally and automatically aligned with that ontology. So basically, you implement the contract that your ontology defines. that's the idea, and it's as simple as that. So we're going to have an ontology, we're going to have some CSV files, we're going to have Neo4j, and we're going to show how the whole thing, all the elements fit together, and how we can, using a bit of Python. So today is going to be a bit more code heavy if you want, but I hope it's going to be easy enough to follow for everyone. So that's the idea. Any questions so far? Does it make sense? So it's
that totally makes sense.
I guess probably worth mentioning that all the code that we write, so all the examples will, of course, as usual, be available. I mean, the recording will be on our YouTube channel, and all the code will be on a GitHub repository available for you just after these sessions. So don't worry about trying to catch things.
Link to that or is already in the description. Obviously, the content is not there yet, but if you click on that link in the description of the video, you'll find the repository.
Perfect. So, well, actually, I've been talking over the title and should have been talking over these first slide, because that's exactly what I was talking about, right? So what we have here is a data platform, Neo4j, and we want to align, because we're in the process of building this knowledge graph in Neo4j. We want to align the model that we build in Neo with some explicit description in the form of an ontology. And I was mentioning before some of the most popular ones, but it can be really any ontology, right? And the idea is that this idea of a model mapping, so we're going to have to somehow say, well, this is how the elements in the ontology map to the things in Neo4j. And that helps, like I was trying to describe, defining this data ingestion pipeline and automate it to some extent, to a full extent in some cases, as we'll see, but also to be able to define APIs. I mean, of course, the expectation, since we're building this graph in Neo4j based on the entities defined in the ontology, it should be natural to be able to expose it, and that model will naturally align with the ontology. And if we use something like RDF, you get support out of the box from Neo4j, right? So that's the idea, and the important thing behind all that, and we're talking about the definition of data ingestion pipelines. We're going to try to build the notion of automating this process, because an important thing behind, essential to ontologies is the fact that they are formal, right? I won't spend too much time today in defining ontologies, but an ontology is a domain model, like I've defined before. It describes the entities in your domain and how they relate to each other, but it's described formally. And there's a number of standard vocabularies, W3C standards, that help you expressing it in a machine-readable form. That's what I mean by formal. It's something that we can parse, that we can write code against, and that we can automate processes against. So just to illustrate this idea, we have a small fragment of the FIBO ontology. The FIBO ontology, for those of you who are not familiar with it, is a domain ontology for the finance industry. And in an ontology, we'll find things like classes or categories. So this section there, as you can see, this is an XML serialization. There's some others. We'll be using others today that are probably nicer than XML. But an ontology defines categories, defines things. In this case, the ontology is defining what a privately held company is. That is a node. I mean, it's describing an entity, a category. It also describes further down what a stock corporation is. And there's fragments of code in there that indicate that the first one is a subcategory of the other one. And there's a keyword, subclass of, in the RDFS vocabulary. So, and as you can see, as I'm reading these fragments, this translates naturally into nodes and relationships. So the main model described by an ontology will naturally describe a graph model that we will be able to build into the data ingestion process. So that's the idea, and there's some additional elements. There's another. The relationships are not only hierarchical, like this subcategory of, but there are others, like stock corporation is governed by a board agreement that defines another entity, and so on and so forth. That's the idea. What I want you to get out of this slide is that ontologies are defined formally. Formally means, in some machine-readable language, that we will be able to process and analyze and use programmatically. That's basically it. And from here, I'm going to take a 1 second pause to see if there are any questions, and we'll move straight to our environment to show you what things look like. Make sense?
Could you? Yeah, makes total sense. Could you say that ontology is basically like a standardization of a concept of some sort, and then by migrating it over into a graph or knowledge graph, you add your respective, topic. I don't know how to say it now. Like additional information to it that is more relevant to you outside the standardization that the ontology is carrying.
An ontology is just a collection of all the it's a graph schema in our terms. I mean, when you're creating, think of the movie database. In a movie database, we're going to create people, person nodes, and movies, and there will be relationships between them. So our ontology would define there's a notion of a person and there's a notion of a movie. There's two concepts. I mean, they're typically called classes. So it enumerates all the entities that exists in your domain. And it also gives more details, like a person will be described by a name or a surname or a date of birth. So there will be a number of attributes. It's literally a schema, and then there will be relationships between them. A person relates to a movie through a acted in, because in that case, it's a person that acts in a movie or directs a movie. So this is the kind of things that an ontology captures. So an ontology is a formal representation of these sort of descriptions of entities in your domain, but it's ultimately a data, if you want, schema for a database. That's kind of the analogy, right? So yeah, I was mentioning before that we have everything in this repository, and we'll send the link at the end. But we have in our Going Meta repository, you have folder for session 5. And we will see that we have an ontology there, right? So it's a very simple one, right? And it's about the railways. It just defines a couple of categories. And I've created this ontology using Prodigy. I mean, you might be familiar with it. I will not go into the details, but there are ontology development environments and applications like this one where I can define my classes. In this case, there's a station. I mean, I'm describing the railway network in the UK. So there's the notion of a station, and then between stations there are links, and then we have events that are incidents that affect stations. So it's a very simple model. If I build it like that and I export it, that will look something like what we see here. So the first thing you'll notice is that this is not XML.
Zoom in a little bit.
Oh, right, zoom, of course. Yeah, let me make that a bit bigger. So it's not XML based. It's another serialization format called Turtle, which is supposed to be a bit more, human friendly, more readable. But in the end, it contains the same elements. So you see that there's a definition of a class, which is event, another class, which is station, and then the attributes that characterize each of them. So you see that an event will have an event description. The idea of a domain and a range defines to which entities this property applies. So this is a data type property, is an attribute, and it applies to events. So basically, events have event descriptions, and the type is a string. Right? In the same way, we have events have event IDs. Stations have latitude, longitude, station address, and some other attributes. And finally, we have relationships here at the top saying that there's a link that connects one station to another station. So it's a relationship between two stations. And similarly, there's a connection between events and stations saying that an event affects a station. That's what the ontology looks like, right? So it's a pretty simple model. If you think of it visually, you have a station connected to other station. So there's a link that connects one to another, and that forms the network. And then stations can have events attached to them. That's it, right? So that's the ontology. Now, we want to populate a graph. And, in addition to this ontology, let me go back to the repository. We have also some data files. So we have some CSV files, a list of stations. So it's a CSV file. If I click on it, you will see that it's a pretty straightforward one where we have a unique identifier for the station. We have a code, the name of the station, the 16-character name, the address, latitude and longitude, and so on and so forth. So we have a set of flat files, CSV files, that we're going to be using to populate the knowledge graph. Now, the key thing is we want to write the logic that reads these CSV files and creates the graph entities, but according to the ontology that I've defined. That's the plan. Make sense?
Yes.
Perfect. So let's go to this Python notebook. So let me run it. Hope everything goes well. So because we're going to be using Neo4j, we're going to be writing to Neo4j. I'm loading.
Can you also zoom in here a little bit? Sorry.
Oh, I'll try. Good point. Yeah. Let me know if it's.
Yeah, that's perfect. Thank you.
Cool. Right. So we import the relevant packages here. So we have to load the Neo4j driver because we're going to be writing to Neo4j, and we are going to use rdflib, which is a Python library to manipulate RDF data. So these have been installed apparently successfully. So hopefully that's already good. And from there, we're going to import some of the entities. And I'm going to show you, I'll skip this function. Let's get back to it in a minute. But we're going to first read the ontology, right? And this is done in two simple steps. So if we look here, we instantiate a graph. An ontology that we saw is a graph. So in the rdflib library, they call it a graph. And all we have to do is call the parse function with the location of the ontology. And what I'm passing here is the URL of the ontology that we saw here. Remember one thing when you try to do this thing that I show you is the HTML view, the nice one that we like with the colors, but the one that's machine readable, the one that's actually RDF, is the one that we get in raw. So if you pass the URL, this is the URL that we need to pass. Remember that, because that's one of the causes of errors. And this is the URL that I'm passing here. Oops, went to the wrong one. And if I do that, what we'll be doing is loading into the graph G this ontology, all the triples, all the RDF that forms this ontology. And once I have it loaded, I'm going to be able to run queries against it. Now, RDF uses a specific query language, which is Sparkle. I've tried to write a simple fragment of Sparkle here, where we basically list all the things that are classes, which are the classes defined in my ontology, the ontology that I've just loaded here in G. So if I run that and iterate over the elements, let me comment this out and add here. So if I do that, it will run the query and it will iterate over the results, and it will print on the screen the list of the classes that are found in this ontology. And we find two. Not surprising, we find event and station. That sounds familiar, right? If you remember when we scanned, we had two classes, event and station, which are the ones that were defined in my ontology, right? Instead of showing the shortened version like here, it will give me the full URI. So we have a library that makes it really easy for us to load the ontology, put it into a graph, not a Neo4j graph, not yet, into an RDF graph, and run queries against it. And then we can extract things from it. And I've created a utility function up here. That's the bit that I had skipped, which basically it's two functions that get the local part and the namespace out of an entity. So, for example, if we, like we saw, the classes are defined by a full URI, this function will get the local part. I mean, the more human readable part of the name, the event, the bit after the hash, if you want, or the namespace. So if we rerun the same function but use these two utility ones, if we get the local, I mean, this is the complete URL, we can get the local part, which would be just event, or we can get the namespace, which would be the prefix before that. These are useful because we're going to use them to actually generate dynamically our Neo4j loaders. So, right, we have a way of, like I say, explore programmatically the ontology. That was the important bit. It was formally defined. That's why I can parse it and query against it. Now, instead of listing just the name of the classes in the ontology, I can do something more advanced, more sophisticated, which is something like, okay, let's not only get the classes, but let's also get the properties, and let's get the relationships between them. And instead of just printing them out on the screen, I'm going to print them in a text structure that looks like a cipher instruction. So basically, can I programmatically generate some cipher using the information in the ontology? And the answer is, of course, we can. And the idea is the same. I mean, we have the connection to the ontology, and we will do it in two steps. I don't necessarily want to go into all the details. The code is up there, and you will free to have a look at it. But we can. I do it, like I say, in two parts. First, I get the classes and the properties. So it will not only get the class, but it will also get the data type properties that we saw that apply to a given class. And then I will process them and put it in a way that produces cipher. And then I will do the same with the relationship. So I have another query that extracts the relationships and gets the source and target. And it, again, iterates over the results and put it in the form of some cipher. Oh, near cipher. Let's have a look at what this produces if I run it, because it's quite interesting. So that starts to sound familiar, right? So look at this. I mean, that we have generated for each of the classes, for each of the entities, something that looks like a data ingestion cipher fragment, right? So what we're doing here is we are creating a merge event. I mean, an event, a node of type event, using the merge instruction, right? So there's no magic in here. There's a template to the query, as you can see, and the same here. So I'm generating these unwind, these merge. I mean, the bits that are generated dynamically are the elements that come from the ontology. So I'm producing here practically all the bits that I need, right? There's some elements missing, and let's analyze that. So I'm creating a node of type event, and I'm setting all the properties that an event has according to the ontology. In the ontology, I said that an event has an event description, an event ID, an event type, and I need to populate those, right? So that's the structure that I need to complete. There's some missing elements, of course. How does that map to the file that so which is the column in the file, which is the file, and which is the column in the file that I should use to populate that property? And the same, I mean, at the moment, I just created the skeleton, right? So, and I do the same for station. And I iterate over the properties for a station, the latitude, the longitude, the station address, the code, the name, and I have the skeleton of this instruction. And the same with the relationships, right? So now I know that the relationship effects will connect an event to a station. And that's the logic in cipher. And the same with a link. A link connects a station to the next station, right? So as you can see, it's just a few lines of cipher. I mean, there's a bit of complexity if you want on the Sparkle, but we haven't been beyond 24 of lines. And most of it we're printing, right? So there's not much complexity. I know what I'm doing is pretty straightforward, but I'm reading the ontology and using the elements there to define loaders. Quick pause here. Does it make sense, Alex? Is it?
I mean, it looks a little bit overwhelming when you look at it in the beginning, but now that you explain it, I think it's pretty straightforward.
Yeah, and in the interest of time, I'll skip some bits, but that's the logic of what we're running here. So happy to, if there are questions, to go over the details, but essentially that's what we're doing: reading the ontology, extracting the bits that we find relevant, and creating templates that implement the data ingestion. There's a missing bit here, right? So we need three things for this to work, right? For those of you who can cipher, and I count you in those, of course, Alex, you see that there's three things that we need. First of all, we need to map this fragment to a file. I mean, I need to know, where do I load the events from? So the load CSV from, right? So we need to say which is the file that contained the events. So basically, I will have to somehow tell my my generator that probably the one that contains the events is this one here, right? Something like that. That's the first thing, and that applies to all of them, right? So I will have to say, where do the stations come from? I'll have to give another file. Where do the relationships that connect events to stations? So this is the first obvious thing. So where do I feed these nodes and relationships in the graph from? So I need a reference to the file. The second thing that I need is, which is the unique identifier? So how do I mean, which is the property that uniquely identifies an event? Because I'm merging, right? And when I merge, I need a unique identifier. And I need to say, okay, when you refer for a second time on a second link to the same station, because they both have the same ID, and I have to determine which is this ID, merge these nodes. Don't create a new one. So second element is I need a unique identifier for things. So I need to somehow tell my my processor which is the unique identifier for the events, which is the unique identifier for the station, and the same for relationships, which is the source and the target, the origin and destination of the relationship. And then finally, the last bit is, how does each of the properties in the ontology map to the columns in the files? So for example, let's look at the station, right? So we see that there's a property that I define in the ontology called lat, another one that's called long, station address, and so on and so forth. But maybe there's not an exact match. It would be ideal if they had the same name. But if we go to the station file, it's quite common that the columns might not have the same name. And you see that the code happens to be called CRS because it's the standard acronym. The address is address instead of station address. So I'll have to say this is how the relationships, the attributes and the elements match to the columns in the file. So that's all I need. And this is if you want a mapping definition. So that's what I meant before. So I have to somehow align the two. I could do this manually, and we'll explore that in a minute because we have a tool that's called the data importer tool, where we can actually take the files, take the model, and practically drag and drop and say, this file goes here, this file goes here. So I could do that manually. So from here, I could take it there and say, I'll do the rest manually. But here, what we want to do is try to fully automate the thing. So I've come up with my own mapping prototype, and let's explore it. And I'm gonna run it, and you will see what I'm doing. But I'm essentially doing exactly what I described. I'm defining for each of the entities. This is a station mapping. I'm defining, well, this is the file where the data comes from. Boom, and I have the address where the file comes from, right? The second thing is, which is the unique identifier? The unique identifier is the station code. Now, station code is one of the properties defined in the ontology. Now, some people will ask, and I will not go too much into the details. Of course, we're kind of covering a simple example that we can cover in today's session. But there are attributes in the ontology, like inverse functional and things like that, that can indicate that something is a unique identifier. Of course, we can explore that, and in the real case, we will. But for this session, let's put it like that. I will explicitly say here, the unique identifier for a station will be the station code. That's what uniquely identifies it. And then the rest is a mapping. So for the lat property in the ontology, you get the lat column on the file, on this file that I referred here. For the long is long, for the station address is address, for the code is CRS, the station name is name, etc., etc. That's it. So, and I do this mapping for the stations, I do the mapping for the events, I provide the file, I provide the unique identifier field, and the rest of the mappings to the fields, to the columns in the files. For the relationships is a bit different. It's just a relationship. All I care about is the file, of course, and then the from and the to. A relationship, I just need where does it start, where does it end, which are the entities that it connects. So origin and destination is the field, the columns in the file. So let's look at that. If we go to data and we look at the links, it might be a longer one. I don't know if it's going to be displayed, but you see that it has origin and destination. So all the links in the network is a connection between one station and the next station, adjacent one, with the distance between them. So that's what I'm saying here. From and to is origin and destination, and for the events is ID and station. That's the mapping. So if I run it, I'm showing it, and that's what we have defined. So that's kind of the glue that links the ontology to the model, to the files that I want to load, and it's the bit that is going to help us completing this picture. So it's going to produce with this mapping. You can see how that fills all the remaining gaps here. It's going to generate a complete set of cipher instructions that will actually run. So with this mapping in use, defined in the variable rail mappings, I'm going to run exactly the same code that I ran before with a couple of additional extensions, and I put it on a file. I call it get loaders from onto. So the Neo4j loaders from the ontology, and what I pass is the reference to the ontology, the format for reading, and the mappings, this mapping that I had just defined. But the logic is exactly the same. We read the properties, we generate the code, we read the relationships, and we map the code. The difference is that now we actively use the mappings to populate some of the fields, right? But if we test it, and we can go back to the code in a minute, it will be as simple as that, right? So we are going to run the function, get, that will be, did I call it GIR? I would say get, not GER. That's my mistake. Let's call it properly get loaders. So that's the function that I want to define. And let's invoke it properly. Get, not GER. Get loaders. So, and I pass, like I did before, the location of my ontology, the turtle serialization, which is the one that it's using, and the mappings that I've just defined. If I do that and I print the results, I will get something that's totally valid cipher now. If you look at it now, it's produced for an event. It's using the event ID as the identifier, and now it's mapping to the actual columns in the file, right? And that's just using the mapping for that. So this is valid Cypher code that will be executed, can be executed, and will be executed. And the same for the relationships, for the stations, and then finally for the relationships, the event to station and the station to station. We'll get to this bottom part in a minute. So what we have here is just the sequence of, and the files for each one of them. So we have a sequence of statements that I can automatically run and populate my graph. Let's do it, actually. And before I do that, I've stolen this function from, I can't remember, it's someone from your team that is just a batch inserter. I mean, it iterates over a file and creates batches of a given size. If we want to load like a file with hundreds of thousands of lines, instead of doing it in a single transaction, what we do is we break it down in small micro batches. So that's the logic that it implements. I won't spend too much time. It's pretty straightforward, right? So it takes a frame, a data frame, a pandas data frame, and it will iterate over the its size and will define chunks of the given size, and it will invoke the right to Neo4j based on the logic that we pass. So here's the final step now. So what we're doing here is, first of all, we're connecting to a database, and I'm using a sandbox that I have created, and that should be actually accessible here. So this is the sandbox that I'm using. As you know, you can create your own very easily, and you have all the connection details when you create it. So that's what I'm using. I'm passing the Bolt URL and the username and the password, so the credentials. And what I'm doing here is, okay, I'm starting a Python driver session. I connect to my database, and I select the database because Neo4j can host multiple databases. And all I'm going to do is call my get, not get loaders from Onto. And the thing is, I'm going to store the results of that in these variables, and then I'm going to iterate over them and basically write a log to indicate what we're doing. So I'm about to import one file, and I'll call the insert data function that I define up here to just break it down in chunks and do the writing to the database. So let me run this and see if it doesn't like it. And that would be because there's something that I've not imported properly. Let's see what the error message. Mappings is not defined, of course, because we called it differently. We called it railway mappings or something like that, right? It should be up here. Rail mappings. Here we go. Let's copy paste this. So if we scroll down here, the parameter that we want to pass. Oh, it's rail mappings. That should be good. So with it, I have to use it here as well. So there was an error. So rail mappings and rail mappings as well. Okay, hopefully that does the trick. So now it's about to write events, start writing the events, writing stations, and we should be seeing the results as they come here. Hopefully in a matter of seconds when it refreshes. But it's writing the stations, and now it's writing the links between events and stations, and finally the links between stations. And it's breaking down in batches of size. I believe I said 300. So every 300 lines, it's setting a commit. So as you can see, it's doing it fully automated. It's just reading the ontology, capturing the mappings to understand where to get the data from the files, and just writing to Neo4j. And if we get here, look at that. Yeah. So we have
a database
populated. Cool. So we now have events that affect stations. So you see that there's a maintenance work in this station, Levenscholm, whatever. And this station connects to two other stations. Remember that the link connects to the adjacent stations. For whatever reason, this dataset contains one link in each direction. That's probably redundant. We could have cleaned the dataset, but that's irrelevant at this point, I guess. But the idea is that we've been able to populate the graph, perfectly aligning it with the information in our ontology. So it contains exactly the same set of entities: events, stations, links, and effects. Right. So one thing that happens is that we can now, pretty out of the box, we can do something like get. Actually, let's use post. So, because you probably know that the sandboxes come with Neo-semantics pre-installed, so we can say Neo4j is the name of my database. I can run some cipher and get the results of my cipher serialized as RDF. So if I say, well, let's put it here. Let's write a very simple query, right? So let's match a station of the place where I live. So that's, I think the name is, we call this station code. So we use station code. Station code, I think the code is HPD. I cannot use quotes inside quotes. It's not going to like it. So let's use single quotes. And we return that station. So return just this station. It's a very simple fragment of cipher. And we're going to serialize it as, I don't know, as n triples, for example. If I've made no mistakes, boom, we can generate RDF out of our database. And the most interesting thing is that, look at that. We are using exactly the terms defined in my ontology. So I'm not only calling, I mean, internally I call it long, of course, because, I want my database to be, nice and easy to manipulate, and I don't want these long names. But when I export it, I mean, we're clever enough to say that this long maps to the long defined in my ontology. And let me go back to here. So if I go to C session 5 and we go to ontos, we will see that long, there you go, is defined exactly with this URL. So the mapping is perfect. And we can, here, expose out of the box the model that we've created, the knowledge graph that we've created, aligned with our ontology. So we've used the ontology to ingest in a fully automated manner. And now the graph that we've created is obviously naturally aligned to the ontology. So if I publish and we have this out-of-the-box RDF endpoint, that aligns perfectly with our ontology. So I think that worked quite well. I hope it kind of made sense.
Yeah, super cool.
I know there are bits that, like you said, they might be a bit daunting, but I'll share the code and you'll see that there's no magic in there. That's pretty straightforward. And right, so there's one kind of thing that I skipped over briefly, and it's this idea of, I mean, the model of course aligns with the ontology because I've defined entities based on the entities defined on the ontology. But there's a step where I made explicit the fact that, hey, when you have a station, this station actually is a station as defined in this ontology, right? It's this one down here. That's what I mean by station. This is important in RDF when you refer to an ontology, because things have to be uniquely identified and non-ambiguous. So that happens as a side effect of this generation. So this is the fragment that I skipped before. So we define a number of mappings here, but again, these mappings are generated on the fly. And in our case, the mapping is immediate because we're generating the model out of the ontology. So all I need to do is expand the local names in Neo4j with the URIs from the ontology. So it's basically, in Neo4j, I don't want to have to handle URIs. It's a bit, too cumbersome, too verbose. So that's what I do. And this is generated, like I was saying, on the fly as we parse and process the ontology. So we generate the data ingestion, but we also generate the export mappings, which is this fragment that we're using there. So right. So I hope that made sense, and that shows how we can take any ontology and apply this process. I mean, the only bit that you have to kind of customize is you will have to define a mapping. So this thing that I did is something that at some point will have to express how my source files map to the ontology, and how do I pick ones or others to populate the graph. So
there was just a question about the mapping, and maybe we do a future episode on this, possibly. David wants to know where I can learn a bit more about mapping to different ontologies by using Neo4j, and you just spoke about mapping as being a crucial part of it. So maybe that's something, I don't know.
Very good point. Because like I said, I went intentionally with a simple example that could be covered in this session. But of course, life is not that simple, right? So when sometimes we don't have everything defined in a single file, and we will not have everything just as a set of a couple of classes and properties. Sometimes information comes from different places. We have to combine multiple elements from different ontologies, and that's something that we are starting to include in neo-semantics. So that's a perfect segue to go into a second version, much more probably user-friendly, of less programmatic and more visual, of exactly the same process, right? And like I say, unfortunately, the code for this is still not in the current release, but it will be soon. I mean, it's checked in already, so if you're curious, you can have a look at it. But the idea is as follows. So I want to be able to generate from my ontology, and again, like I was saying before, I will go to my raw version of the ontology. I take the URL, and I could take, like David was saying, schema.org, Fibo, a combination of them. So what I need to do is call this method in neo-semantics, and this bit I'm running locally because it's, like I say, it's still not in the release, but I'll do something like call ntns, and there is an experimental procedure that generates a data imported model, and it streams it on the screen. Let's do it like that. So what it does, no, it's not inline. I want to have the fetch. Yeah. So all I do, just like I did before, is pass the location of my ontology, the serialization format. And if I run it and that doesn't produce any error, that generates quickly on the file.
Can you zoom in here and this?
Oh, yeah, sure. Yeah. So the method that I called is this. Like I say, this is still not there. Give it a, I don't know what the release process will take, but in the coming days, that should be there. So ntns, like all the methods in neo-semantics, ntns experimental, because it's still, kind of a work in progress one. And it also links to the data importer tool, which is also kind of evolving very quickly. But it generates a data imported model based on ontology. So I pass the URL of the ontology, and it produces this. Well, first of all, a JSON file that I'm going to show you what to do with it, and then exactly the same mappings that we defined before, right? So, so what will I do? I mean, for now, there's two versions of this. So there's the stream method. There's also the, I believe it's called write. So if I do the same, this will, it's not like that. It's called something else. Let's find out. ntns experimental export is not write, is export. So if instead of write we say export, and I run it, it will save it locally. It would put the same content in a file. But this file is interesting, and let me show it again. So if I go to stream, this file is actually a configuration file for the data importer tool. What that means is if I have the data importer tool, exactly. So now I can say, okay, let's go find this file, and I'm going to open the model. And this is, it will be also for you. You can generate it, of course, the moment you have this procedure, but it's in the session 5 in other. So it's this model. And if we open it, look at that. We have the event, the station, and the link. So we already have it done for us, which is exactly the same we were doing before, but we're doing it, we're doing it visually. And now what's the next step? What I'm doing now is do the mappings manually. So I'm going to say, okay, give me the files. And the files are also there. So in the data folder. So I'll grab them. I'll open them here. And I'll do the mappings manually. In the other case, I was doing it programmatically. I'll give you a definition of which field goes where. Here, because I don't have it, I have to go and say, okay, station comes from the stations file. That's what I did in the mapping before. Here, I'm doing it manually. And now I'm going to say, of course, file by file. I can remove some of the elements to make it quicker. We can remove the label, but then I have to define the mappings. And I can say, okay, the URI comes from the URI field. The station name comes from the name field. The long comes from the long. The lat comes, station code comes from the CRS. The lat comes from the lat. And the address station address comes from address. And the unique identifier is the CRS code. Where was it? Station code, sorry.
Station code, yeah.
Right. Then we do the same with the links, right? So a link comes from the links file. Sorry, I have to do it manually. That's why I like the programmatic access, because it's much fun. It takes a while to write, but it's a one-off. So it comes from the links file, and then the from is the origin column, the destination is the destination. And I can even do something else, because look at that, the links file has an additional column, which is the distance, you remember, which we didn't import before, because it was not in the ontology. And that comes to another thing. In RDF, you cannot easily bring attributes to relationships, but in EF4J we can. So I can say, hey, add from file, something that's there and that I haven't modeled. So boom, I have the distance as well. And let me complete that. So we have the events. Sorry, that's a bit slow, but there's an events file. And let's go to, like I did before, let me remove the label. Let me remove the URI here. Let me remove the comment and just map the rest. So we have the event ID, which is the ID. The event type is type. The timestamp is TS. And the description is a description, desk. And the key here is the event ID. And finally, just to complete the model, the effects also comes from the events file, because the events files, if you remember, had a reference to the station. So it goes from the event to the station. And that's it. If we've made it right, now we can run the import. But before we do that, let me empty my database, because that should be, and for that we have the magic APOC truncate. That should do it nicely and without. Perfect. So we have now an empty database again. And if we go back to the data importer and we haven't missed anything, we can run the import. I already have the pointer to my sandbox with the credentials. So if I run this and nothing has gone wrong, fingers crossed, that should write. And it's, if you look at it, I'm basically look at the code. It's exactly the code that I had generated before. So these are the, that's great if you're doing playing around with the database. But in a more kind of production environment, you want to automate the data ingestion. So you will probably go down the programmatic approach. But this is great because again, you get your own. Well, that's written to the graph, and hopefully we have exactly the same graph that we had before with the links, with the effects. So pretty much exactly the same thing, but once, like I said, done fully programmatically, and the other one with this manual step that's in the data importer tool, which is also cool. But the key, kind of the glue that links the two things together, is these are the files, and this is how they populate the elements in the ontology that are basically created as categories or classes or in my graph model. So I'll take a pause here to breathe and
I guess this
question here, Alex. Does it make sense?
It makes total sense, and it's cool to show that this two approaches generate in essence the same code. I guess what we are showing here also is that with the data importer, if you are not, if you just start out with it, have a fragment of your data maybe, and want to see how it works, how it looks like, have a more visual approach to modeling, to mapping the respective files across to your graph database.
Mm-hmm.
This can be helpful to see it first before writing a page of code, which then might create more hassle. But obviously you're right. I mean, if you want to productionize this needs to be automated. But for initial first step, I think the data importer is great. And then also with this new function you just showed in Neo-Semantics that gives you the model,
exactly.
You won't make, I mean, you won't make much errors in modeling. You can extend the model if you like, but the baseline will be correct and will be perfectly mapped on your ontology.
Exactly. That's the idea. So we can, and we can probably do, I see it's 10 to 5, so we can probably give it another try, because I showed this simple model that has stations and events, but maybe how things go when we try things on the fly. But I'm tempted, and you see what people say. There's for example schema.org, which is one of the popular vocabularies out there. So let me paste it, and is that the that's going to download it. Let me use the TTL version of it. which might open in the browser. There you go. Well, that's a very large ontology. Look at that. So I'm not going to scan over it, but schema.org, and let me show you a much nicer and readable schema.org here. So it defines loads and loads of entities. For example, let's look at the person entity, and it defines additional name, address, affiliation, blah blah blah, all these sort of things, right? So let's say, okay, this is already there. I mean, it has a huge amount of properties. I don't know if I want them all, but why not? Let's give it a try. So let's say I want to.
What can possibly go wrong?
Exactly. Well, but it shows that it clearly has the experimental tag on it. So
yeah.
But some of the things that people like is, hey, I'm creating my knowledge graph, but I want to align with schema.org because already it defines a set of properties, and I want to align with them. Why not? Well, perfect.
Yeah. It is a valid approach.
Exactly. So there you go. So let's say I want to load person information, because the thing is, like I was mentioning before, we have a huge amount of elements in this ontology, and that gives you a feel of that, right? So it defines, I think, hundreds,
yes.
If not thousands of entities. So I don't want to bring all that because it would be crazy. I mean, this is a domain that covers everything and anything. So one of the things that I can do with my with this function that I was using here, it's a bit too big, but is I can restrict the list of classes that I import, right? So I can say, okay, go load it from here, from schema.org. That was here. It's the location of my ontology. I'm using instead of the TTL, I think we were using the N triples. I'm following the guide that I use at Graph Connect. Yeah, NT and the N triples one, right? So let me get back here. So if I run that, it will generate the whole schema.org, which would be crazy. But here, what I'm going to pass is a list of classes that that can that restricts what I want to import from the ontology. And I was saying before that I want to load person, right? So let me find it here to see how it's defined. Schema colon person, and schema again, if we go to the top, is this namespace. So let's provide the full URI. So essentially what I say is go load this ontology, but don't bring everything, just bring the person entity. And still it's a pretty large one, but let's give it a try. So if I do that, of course it doesn't. What did I do wrong? Expected map. So what's let me see the signature of the method. N10s experimental stream. So it takes a URL, the format. Oh, it's a map. What is that map? Oh, it's it's not a list, it's a map, and I believe it's something like so the property is class list or something like that. Will I find it? Let's see. I might even need to go have a look at the source code. That's going to be,
Okay.
Yeah, there you go. That's how we roll it here. So
yeah.
So class list. That's right. So there you go. Let me go back here. So I have to say that the class list this is a list, yeah. So that's the proper syntax. So if I've made no mistake this time, now it goes and as you can see, it produces exactly the same, but now it restricts itself to the person ontology. So it's still going to be long, as you can see.
Yeah, we saw that.
There were loads and loads of properties.
Okay, that's long. Yeah.
But well, let's see. I mean, we might make the what's it called, the data importer explode, but go wrong. Let's see. Okay, so let's bring this, and we can go to dev, going meta, and there's session 5. If we go to other, we have the iModel. Let's call it schema.org, and it's JSON, a JSON document, and let's paste it there. Boom. There you go. So we write that, and let's see what that looks like. So we're going to clear the model. Yeah.
Mm-hmm.
Why do we do that, Alex? I mean, it was also going so well.
It was all going so well. Now I can only end up either it's going glorious or it's a crash.
So we have the schema here, and we open it, and boom! Wow, that's not too bad. So that's brilliant. But, you know, we have a person, hopefully with a long set of properties as expected. There you go. Boom.
Indeed, yeah.
So it has all the things that are defined in schema.org, and you might want to then delete the ones that you don't care about, or even, you know, we can add something more refined in our method to restrict the bits that you care or you don't want imported. But then you have all the relationships. Look at that, because there's, I mean, a person knows another person, so that's a reflexive relationship. A sibling is a person connects a person to another person. So this is, you know, exactly what we wanted. So that's you know, brilliant. We were lucky this time. I mean,
yeah. No, that's not luck. That
doesn't exist. But anyway, I hope that was but we could do exactly the same with the other approach, right? So we could point at that ontology, and like we did here. So instead of using our railway ontology, we put a schema.org. We restrict the classes that want to extract, and not necessarily all of them, and we would generate exactly the same kind of runnable code that we generated here, and we could have it executed and our graph populated. So, well, I'll stop here, and yeah, I think it's 58. So if there are any questions, we'll answer them, and if not, I think we'll just end the session here, and like I said, you know, leave the code there, and hope to hear from people and for people to provide feedback and see how these things can be improved. But again, I guess the idea that should live with today is, you know, an ontology is a way of defining a domain model, and we can use that to drive the data ingestion, whether that's through the data importer tool, whether that's programmatically. That can help us, you know, create a graph that aligns with our contract, if you want. Understanding a contract as in, that's how our organization understands the world. I mean, a person is defined as, you know, for example, we saw in schema.org, or in an enterprise, you know, a customer is defined as these, and these, and relates to. So it defines a canonical model and vocabulary that we can easily align with by following the process that we covered today. So that was me.
That was amazing. A super cool demo. People in chat love it. So Raza, that's just amazing. David, really nice feature. Others. So I think people. I mean, you said you don't quite know when it's going to be released. I think that is definitely a feature that that is very interesting to lots of people.
Yeah, absolutely. And the thing is, you know, since it's tagged as experimental, I'm keen to have it out there and people playing with it and get feedback as soon as possible. So the code is checked in. So it's more a question of me reaching out to Max and getting the release process started, and it should be ideally before the end of the week. So we'll make an announcement. So follow us in, you know, on Twitter, on all the channels, and we'll let you know when it's there. But it's imminent. So that code is already there.
That's very cool. And then I guess feedback to you on Twitter or directly in GitHub, I assume.
Absolutely, yeah. If it's kind of code, if it's more technical, probably GitHub, or direct in the community as well. The community.
Of course, also community. Yeah, that's
where it's a great way to interact and hear about people's experiences. So
yeah, and I guess this is the perfect demo. I mean, you can now, if you watch this, future us, if you watch this, and it has already been released, try it out, test it with the code we provide in the repository and going meta, or try it out with your own code. And if you find anything that's strange or you know any issues, report them back. But I think this was a great demo, and it's I mean, especially with the linkage to graph importer, data importer, for lots of people who may be shying away a little bit with all that writing. initially it helps a lot. It makes you understand the data model a little bit better. You visualize. I mean, at least if you're more like myself, I guess, a visual person, saying, okay, I can see this. I see here the relationships. I see the nodes, and then I can map it out. And then I try it and I.
Yeah, I was going to say, you know what? I mean, one of the things that I like when we see things in action, right? Because we've heard the term ontology 1,000 times. We can spend weeks and months defining an ontology, but now we've seen an ontology being used to create a data pipeline, or an ontology being able to define a visual model that we can. So that I'm one of these people that understands things when you see them, and when you see them in action, rather than trying to define it in an abstract way. So if people live with, that's one of the ways in which we can use ontologies. I mean, we'll talk about others, and we'll come back to that. But that's one thing. An ontology is a contract, as a definition of a domain, as a canonical model of how we talk about things, and how that can be used programmatically or visually to create your knowledge graph. So that's I think that's the key takeaway from today's session, hopefully.
Perfect. And with that, I think we are ready to finish this session. Thank you all for watching. Obviously, big thank you to you, Jesus, for presenting and for especially showing the demo, and then adding another live segment to end at the end of it, which was not planned. So that went well and was great to see. If you are interested in watching more Neo4j live content, we will be back tomorrow with I think that's the final episode of Laurent's and Glenn's PHP client episode number 8. Yes, I think that's the final episode. Tomorrow, 5 p.m. Central European time, so basically the same time slot as we were now. And Michael and I will be back on Monday with another Going Meta episode.
No, Going Meta will be in a month. Michael and you will be
sorry, yes. Yeah, exactly. Discover Aura will be on Monday, and Going Meta is taking place in July.
Basically, seeing you on the first Tuesday of July, right? That's
on the first Tuesday of July. Exactly, that's the plan. I think that's 5th or something. Yes, 5th.
I'm sure we'll come up with some other cool topic. But, yeah, looking forward to the next one.
Yep, perfect. Thank you all for watching. Have a good rest of the week. Take care, everybody, and see you soon. Bye.